So I'm going to start recording. Today is going to be a traditional lecture. This week, in fact, is going to be a traditional lecture on file reading, which is actually easy peasy in Python. So a big thing here, though, is let's just talk about undergraduate midterm reports and that kind of stuff. So I tend to be highly aggressive in handing out unsatisfactory ratings. So you should, by the end of the week, you should have everything uploaded onto all your grades should be on Canvas for you to see, when everything should be graded on Runestone. That has a due date up to Friday. So those should be graded. So that should tell you where to go. If there's issues with it and you don't have proper grades, just let me know and I'll fix it. Okay. I'm going to assume that you did the work. Now I did have to reset one of the questions because the regular expressions that were trying to find your answers wasn't working for the rainfall problem. So that problem got reset. I'm sorry if that's an issue for you. Just let me know. Now I'm going to get that completed as soon as possible, please. So now with regards to, if you receive an unsatisfactory rating from me, as you know, for this course at the midpoint, don't panic. Like I said, I'm highly aggressive. It may just be that I also completely missed you in the 150 people in the dropdown and I clicked on the wrong person. So, but I tend to be highly aggressive so I can give a wake-up call to the students who need it. It has no future impact on your grades. I don't remember who I give these things to at the end, because all the names just kind of blur together at the end. So, don't think that me giving you that gives you a poor judgment on that. So this week you've hopefully have been introduced to the lab for this week. This upcoming week, this Friday, we're going to be doing the thing that puts everything together, which is the file reading, for loops, if statements, turtles. So it's going to be really fun. And it's actually going to seem like it's one of those concepts in computer science that tasks that look difficult can be surprisingly easy. All right. So give me 1 second. I'm going to get rid of this gum because, it's hard to talk with gum in your mouth if you're lecturing. So let's go ahead and get started. I'm going to be doing today by basically live coding. That's how I generally do this. If you lose track because, it's hard to maintain concentration for more than 15 minutes, no worries. If you have questions, just simply throw them in chat or direct message me. Okay. So let's go ahead and get started. So close VLC because I don't need that anymore. I was testing something out. Okay, so let's talk about files. Files are discrete pieces of data that are stored on your computer, right? And while there seems to be like a million file extensions out there, there's only in reality two types of data: binary files and non-binary. Text files and non-text. Text files and binary files. Or as another way of putting it, text files and non-text. So for instance, here is a PDF of Grimm's fairy tales from Project Gutenberg, right? I'm not really going to go through it in its entirety because, of course, it's not exactly, this is the original text, which isn't exactly like the most socially, respectful thing, So plenty of a lot of these stories are unsurprisingly highly anti-Semitic, but it is still free and easy to get because it's copyright free. Now it's a PDF file, so it's made of a bunch of text. But if we try to open it in, say, a text editor like this, because I get this indication you may not be able to see it. This file is not displayed in the editor because it's either binary or uses unsupported text encoding. So binary means that basically that it is not a human readable file. It's just kind of encoded. Or it uses unsupported text encoding, meaning in other words that the code that somebody had set up that translates letters into ones and zeros is not something the computer recognizes. I'll open it anyway. So if I try to open up a PDF in something, it looks like this. Okay, I'm going to Control F and look for Grimm's anyway. And we'll see that there's generally, nope, not getting any text in here. So generally there's kind of a combination of some text and non-text, but you can see all the symbols and stuff. And this is because binary files, they are meant to be read by a computer or a specific application. We won't really work with binary files too much. Binary files are things like MP3s. They are things like any kind of music file. So MP3, FLAC, WAV, those M4As, those kind of files are binary. MP4s, VP9, MKV, WebMs. So any kind of video file, those are also binary files, because in order to interact with them, you need to put them in an application. Okay. Let's see, PDFs, Word documents. Those are all, despite those being text files, as we've seen, right? Despite this being like a bunch of text, right? This is all just a bunch of text. Opening up in a PDF reader doesn't work, right? It just doesn't, opening this up in a text editor doesn't work because it's not just text. It's much easier to understand this concept if we instead open up The Cat in the Hat by Dr. Seuss, right? How in the world would you represent this in a text editor? Most of this is pictures, right? Right? Even though we have words here, which could be OCR'd, in other words, the computer could figure it out and optically scan recognize the characters, right? So I think this qualifies as fair use, but anyway, it doesn't really matter to me. So Cat in the Hat right over here, right? This is we've got all these pages here, and they are encoded in different form, in like a picture format. It makes sense that we can't open this as human readable text, right? On the other hand, here's the complete works of William Shakespeare, which we'll be doing a lot of work with today. This is, I'll probably go ahead and use a much smaller bit of text from him, but here's his sonnets and stuff. So the complete works of William Shakespeare in a text file, which is human readable. So this is the kind of files we are going to be working with. Now, that being said, most of the files that I've mentioned will most binary files like music files or PDFs or Excel spreadsheets. There are various libraries that exist that allow us to interact with these things, then do the heavy lifting of translating it into a file we can understand. But the concepts apply. What you need are the concepts here. So first for text files, like here again, classic surprised Pikachu face. I'm a big fan of the meme. If we try to take that and throw it into here, oh, well, the editor recognizes it. But if I try to open it with, okay, I'm going to change the file name extension on this to .txt. Yes, I want to change it. So let's go ahead and drop it into here. It says binary or unsupported text encoding, and it looks like this. So so that actually leads to another point. A file has two parts essentially, or we traditionally think of a file as having two parts, which is that it's got the file name and the extension. So over here we see surprise Pikachu hd.jpg. This says to the compute, which means it's a JPEG file, right? JPG is JPEG. Makes sense to everybody? It's a type of file encoding, right? There's different types of ways of encoding files depending on how nice you want them to look and what kind of a digital artifacts you're willing to tolerate. And I double click on it and it opens in Windows native file viewer. But here's the thing. The extension isn't actually that important. The extension the purpose of this extension, the dot whatever, so docs for Word documents, .pdf for PDF files, .py for Python files. They don't actually matter what they're called. They just the entire purpose of them is to tell people what they is to tell the computer what file to open it with. So if I change this to a PNG file, and I double click it, this tells it open up. It says this is a PNG file, so open it up with the file reader, and it says, aha, surprise Pikachu.hd. I'm going to read the file. Ah, it's a JPEG file, so going to analyze it like that. The .png means nothing. It just tells it to open it up with something. So that's what the dot means. It only is an association with the computer to open it up with a specific thing. Okay. But again, that's neither here nor there. So let's go ahead and do some file reading. So file reading is a pain in the butt if you're working in a language that isn't Python. Python, on the other hand, it's super easy and super convenient, and it's made me it's what made me fall in love with Python to begin with, because I basically was able to figure it out. So let's go ahead and do Macbeth. So I'm going to grab good old Macbeth. Let me go ahead, and if you want to follow, so give me 1 second. I'm going to drag the web page. So I'm going to get it my file from Project Gutenberg. So I'm going to go ahead and look for Macbeth just to show you. So what is Project Gutenberg? It is a place where you can find all sorts of copyright, and sorry, it's www.gutenberg.org, and it's where you can find all sorts of copyright public domain documents in the United States. Copyright law in the United States is a pain, and we like to blame a certain mouse-shaped conglomerate for the difficulties in copyright law, but it's actually a bit more complicated. It does probably have the Gutenberg Bible. It is named after the Gutenberg Bible, the first mass-produced Bible. But the idea here is that we've got documents that we can download. So I'm going to click on Macbeth, and I'm going to drop the URL for everybody in chat. So you can read it online in an HTML file, but that's not particularly the easiest way for us to analyze it, even though HTML as code, since HTML is a type of code, it's human readable. These are not really human readable. These are just simply alternatives. So to PDFs. But here I'm going to click on the plain text UTF-8, which UTF-8 is a type of file it's just kind of the way that the computer translates the text. So I'm going to drop this file for you over here in the chat if you need it. So send to everybody. Here's the text file. It's not horribly big, but it's bigger than a lot of text. So this is the incomplete play of Macbeth. So I'm going to go ahead and save it, Control S, and I'm going to go ahead and move it into wherever I'm going to be working, which is today. I'm going to go to Andrew, and I'm going to go to Classroom, and I'm going to go into the folder where I keep all this code I've been writing for this one. And I'm just going to call it macbeth.txt. Okay. So if you want to follow along, you can, on your own computer, you can do that. So I've got two files there. One is the file reading is easy. And then now I've got the Macbeth file there. It's on my computer now. Okay. And so this is Project Gutenberg's Macbeth by William Shakespeare. And basically it's got all this meta information of this at the top, right? And so Act 1, Scene 1. Macbeth, by the way, so first off, so now that we are 15 minutes in, small diversion, we didn't code anything. I just created this file at the beginning before everybody signed on. So because it's the Python file I'm going to be working with. So bit of a diversion here. If you are ever in need of taking more humanities, as I found I was in the surprise need for when I declared a music minor, and all my music humanities suddenly got switched to being music requirements, which left me short for humanity credit hours for my main degree, and I need 3 more. This will work the same in idle, yes. You just need to create a script for it, okay? If you need to take a class for extra humanities or literature or something, take Shakespeare. Now, why? Because the jokes are hilarious, albeit in early modern English. So they require some translation, but once you get into it, you understand it. But more importantly, right? Literature is a bit of a drag because that involves you maybe having to read something you're not interested in, which can take forever. On the other hand, these are plays. They are not meant to be read. By definition, plays are meant to be watched. And pretty much every Shakespeare every Shakespeare play that exists has some performance, usually high quality. Macbeth has a number of ones. There's a Macbeth with Patrick Stewart as Macbeth. So there's a lot of good opportunities to watch. So Shakespeare ends up becoming like mandatory movie watching every other week. So it makes it a very enjoyable experience, and the jokes are actually quite good. There's a reason. There's a good number of them. So that's my side. If you need more humanities, take Shakespeare. Okay. And I mentioned that specifically because Shakespeare is generally available in most universities. So, okay. So how do we open up a file? So first off, the file you're working with and the file you want to read, generally we want to start them off in the same directory. That's generally where we want to put them, if we don't want to search through the file structure, which in itself is kind of a yeah. So we're going to avoid the discussion of the file structure and the directories for right now, because it works slightly different on Mac and Windows, and I don't want to talk about that. So make sure they're in the same files. So as you can see here, right, I'm going to go ahead and so I've got, come on, Andrew, classroom. So I went ahead and put this into over here. And what we can see is that I've got my Macbeth and my file reading file over here, which is just empty. So how do I open it? Well, conveniently, there's a word for opening a file and or function, and it's called open. Assuming I can type. Open. And so next you give it the file name as a string, which was macbeth.txt. Now note that I am being case sensitive here, right? It's called macbeth.txt over here. That's all in lowercase. And it takes in a second argument, which is, what would you like to do with this file? And we put R because we want to read it. There's other things we might want to do, like W for writing for opening a file to write it, or A to append to it, which we'll get into. But right now we care about reading because that's a way more common operation. So this is generally how you open a file. The name of the file you want to open, comma, R, inside the open function. Data. So I'm just going to store that in a variable called data. We could call it text. I think text actually works better. So I'm going to call it in text. And now, basically, when I was doing my first interaction with file reading in Python, because again, I had to teach myself Python because I learned Java, I was like, so what do I have to do? What do I have to do to, like, now that it's open, to read it? Because it's not just a matter of printing this text. If I try to print it, it says that it's created this IO text wrapper, name Macbeth. So, okay, that doesn't do much. Text IO. What does IO mean in this case?
Information omitted or something?
Good guess, but wrong. Sorry, but at least we got a guess. It means input output. Input output. So IO is kind of like it's a text input output wrapper. It wraps around and input out a way to talk to the computer. So but honestly, it's kind of unnecessary for what we're going to do here, which is what I'm going to do is now I'm going to say for line in text. And what I loved about this is that this worked. It was intuitive and it worked. For every line in the text, print the line. And I run it and, it says, can't decode that byte over there. Interesting. Oh, man. Do we have a weird byte over here? Wait, did Gray Malkin? Interesting. where did it say? It said can't decode byte at position 7456. How weird. Normally this works. Okay. Normally I do this on a different file. So let me go ahead and just double check this error because it says it's trying to do Unicode and can't do that. So it's trying to, okay. I have to do this for this file because you shouldn't have to do this for other files, but it did say it was a UTF-8 file. So I'm just going to tell Python, no, you think it's encoded in this format CP1252, which is, I don't know what that is, but when I downloaded the file, it said it was in UTF-8. Shouldn't have to do this for any other files, but let's see. There we go. And now it's spitting out. It's fine with it now because I told it it's in UTF-8. And so we printed out this entire thing. Now you'll note that basically that if I scroll up in my output, I'm missing like a bunch of the play and stuff. But get thee back, my soul is much too charged with thine blood already, with blood of thine. So let's look with blood of thine already. So it's so like my output is starting at line 47. Now, the reason for this is actually there's nothing wrong. My code isn't incorrect or anything. What's going on here is that, believe it or not, this file, let's go ahead and right click on this file and take a look at it. Properties. It is 127 kilobytes. Now, that is a quote unquote big text file. Big enough that it has enough lines that basically the predetermined buffer of for the number of characters here is filled. So when you run out of text characters in your terminal, it just starts throwing out all the other ones, all the old ones. So if we were to, there's ways to increase that, but that's just, believe it or not, this is a big text file, but it works. It prints out everything and we can kind of see it flash by as we run it.
One sec, Professor, can I take a nanosecond glimpse at the end?
Yep. So I'm going back over here. So it is just 3 lines, which is, hey, open up the file, read. To get it working, I needed this one because it didn't recognize it was a UTF-8 off the bat for some reason. Okay. But really, usually all you need is just the text and the this and the R. And then we say for line in the text, print the line. That's all you have to do. Now note that we've got a lot of like blank lines over here, right? Like we've got, yeah, let's scroll back up. We've got, but get thee back, my soul is much too charged with blood of thine already. So with blood of thine, so we've got a space, we've got a line between these 2 lines in our output, but it's not in our input. Any guesses as to why? Now, the reason this might that it's putting out is because, or putting out an extra new line is because over here we have a new line character in the text file. So what this is doing, so let's go into just kind of summarize this. What is this is going on here? For every line in the text, print it out. So it prints out this line, including the new line character. And then print statement adds its own new line character on the end. So for every new line character, we're kind of getting 2. Make sense? If we want to go ahead and get rid of that, we can just simply say line is equal to line.strip, which will strip any preceding and ending white space. And now we get a much more consistent thing. Now, Steven says, mine says no file existed. So there's a couple reasons for that. First, you could misspell. And let's go down to the bottom and see. No such file directory, macbeth.txt. Also, if you don't have it in the same place, like for instance, if I take it and spell it correctly, but I decide to move this over to the desktop, right? It won't find it. No such file. It's got to be in the same place as where you saved your file, as where your script, Python script is. So you got to have a Python script in the same folder if you want this to work. Make sense? You could just use the relative path to get the file location, but I don't want to do that because that introduces a more complexity than I want to do it at this first exposure. You can use paths, but as I just said, using paths means I have to introduce the concept of file locations and finding file locations, which is a pain. So let's go ahead and do some interesting, see other ways we can read this. So in Python, there are multiple ways to do such things. So I can do text is equal to, I can do, let's see, big string is equal to text dot read. That's one thing. So this is another way to read it, which is big string is equal to text dot read, which just simply takes the entire file and converts it into a giant string. So if we print it out, boom, there, it's the same. It's the file we saw earlier. It's just stored in a single string, right? In fact, we can see print length of string, sorry, length of big string. I call it big string because it's just a big string, and I didn't want to do text is equal to text.read. And we can print out its length, and it says it is 124,000 characters long. Another thing we can do with that, let's see. But let's test something else. Other big string is equal to text.read. I will address that. You can't find it in a second. I want to finish my thoughts here. Print other big string. So notice that I did print big string, length big string, and then I tried printing out other big string. Notice here I've got the length. And then nothing printed out. Let's see. Let's go ahead and work on this. And notice I run it, and so I read it, and then I read it again, and other big string does nothing. So when you call read, what it does is that it reads the file from top to bottom. It actually goes through and reads it until it hits the end of the file. And then it pauses because there's other ways to use the read. You can tell it to read only a certain amount or something. But generally, when you just simply do read like that, it will read, and then you can read some more, and then you can read some more. But if you pass it in with no argument, it's just going to read it all. And if you try to call it again, there's nothing else to read, so it doesn't do anything. So does this matter? Not really, because you're not going to use read. You generally, if you use read, you're just trying to read it all into one big chunk. So how do you read a file and store it in a string? Like this. It's pretty convenient. 2 lines there. Open it up. Now, again, opening it up, you need to have it in the same location. So if you're working in idle, for instance, okay, if you're working in idle, right, you need to have a new file open, and you got to save that file. wherever you've got your, wherever you want to be working on Macbeth. So if you try to save it here in your Python 39 folder, 3.9 folder, not going to work. You need to say, you got to go to wherever your Macbeth file is, or wherever you downloaded it to or moved it to, or you got to save this file somewhere like on the desktop and then move the Macbeth file into the same location as well, right? They have to be in the same location. Pathing errors are annoying, but they're so I'm trying to reduce it by telling you, by giving you a rule. Put your file in the same folder as the file you're trying to read. Make sense? If they're not there, then it's not going to work, right? So if I open this, let's go to Andrew and Classroom and ITP. 2020, 2021. Okay. File reading is easy, right? Here we go, and run it. And I didn't get an error, so it's working just fine. Run it. And it says, hey, squeeze text because there were so many lines. And I didn't want to like output them all at once. So, okay. So you can read a file like that. Another useful function is to do this. Is you can do, so dump text into big string. Iterate over text over file line by line. And now we have another way to do things. The third way that you need to know is we can do all the lines. I'm giving it just big names because I can. All the lines is equal to text dot read lines. And what this will do, print all the lines, is that it stores the entire file in a list separated by lines. So it's a list of strings separated by lines. This ebook, so here, let's look at this. Home. Okay. Yoink. Okay. Project Gutenberg's Macbeth by William Shakespeare. So if you check our output over here, that's our first, that's index 0. Then a new line at index 1. And a new line. And then this book is for use anyone anywhere in the United States and most other parts of the world. So that's 3 and 4. Right? So putting it in all lines does the same thing as read, but it stores it instead of into a big string. It stores it in, it stores each line of text into a list. Which one you want to use depends on what you want to do. But you can get by with just using read or read lines or 4-line in text. It doesn't matter which one you use. Could I add dot strip? I could add what I could do is I could go through and modify each of these things with the dot strip. But as it stands, I can't remove these new lines over here with just read lines like that. So those are the 3 ways to read a file. Now, what can we do? So what we can do is that we can do some interesting things here to analyze the file based off of what we know. So let's take a look at the dramatis personae, or the number of people here. I bet this is where it had issues with putting out the text. So let's go ahead and see how many times Macbeth has a speaking role, because he will be in all caps. Or, sorry, Macbeth. Well, let's see how many times Macbeth appears in all caps. So what we can do here is, let's go and do for num shout Macbeth, because that's the number of times it will be capitalized. So for line in text. So if we go through each item in this, right? If we do this, it will give me line by line. But remember, I'm looking for the number of times that Macbeth is in this, in all caps. So for every line in the text, let's go ahead and first off, line.strip to remove those new lines, just because I can. I like to do that as a habit. The next thing I can do is I can say line is equal to line.split. What is split going to do? I'm going to split on the space, which means that basically I'm going to make it so that I've got only the how to say, basically I'll have Macbeth, comma, general in the king's army. It will be split up when I split it like that. So let's go ahead and just kind of show print line. If I go through and run this, taking a bit longer because it has more to do. But as you can see, it has each word basically in one of these. And then what I can do is now I can ask basically, hey, if Macbeth, I can do a nested for loop for word in line. So for every word in line, so everything in one of these lists, if Macbeth, if word equals Macbeth, word, or I'll go ahead and print it out so we can print out and see how many times. So we'll print out all the Macbeths now in all caps. And apparently we just get it 3 times. Can't be right. Let's see. Duncan, Malcolm, soldier, period. So why am I only getting 3 Macbeths here in this file? Any takers?
Is it because you put it in all caps?
Well, I've got a Macbeth over here in all caps. You have it all in all caps whenever somebody speaks, right?
Because Macbeth ends in a period and not a space.
Because it ends with a period. So whenever we speak so apparently whenever somebody speaks, it ends with a period. So let's search. So for every time we see Macbeth period in this document, let's do a count. Okay. And now instead of doing that, we can say, let's go ahead and call this num. Let's change this variable to num Macbeth. And again, this code and video will be posted. So if you're worried about trying to keep up while I'm typing, don't worry about it. Num Macbeth lines. So there, and rather we'll just simply say num Macbeth lines is plus equal to 1. So we increment by 1, print num Macbeth lines. So he's got 205 lines in the play. Ostensibly, they're good. It's a large file. My analysis might be a bit off, but hey. Okay. So everybody understand the premises of file reading over here. Any questions so far on this whole concept of file reading? Essentially, what we are doing is that we are taking a file and we are turning it into a string of some kind, or we're turning it into a list of strings, because that's what makes it easy to work with.
Yeah, I have a question.
Yes.
Could you scroll up all the way to the top? Yeah. Sorry, I missed the part. What is the UTF-8?
So UTF-8 is the modern way to encode text. It is a compressed version of Unicode, or it's a concise version of expressing Unicode, which is the way we try to direct. We do a text across on the internet and on documents these days. Back in the days of earlier times, we used ASCII, which was an American-made standard, which had only like 128. It specified 7 bits for text, which basically gave you 128 different characters, and then you could use that last bit for 128 more different characters. The issue being is that there's more than is that if you're working in a language like Mandarin, standard Chinese, or say Japanese, or one of many other languages, you're dealing with more than 256 different characters. So, God forbid, now we take into account emojis and stuff like that, right? So UTF-8 basically says it is a format that basically accounts for things like it is able to interpret this. Without it, it was crashing on the AE symbol. But normally it should just identify that it's in UTF-8, but for some reason this file did not advertise itself as such. So in order to just simply keep it from crashing, I had to do that. I have a suspicion that if I delete that and replace that over here, nope, there's probably some other issue as well.
Okay, and how many characters are able to fit in this language? Or
how many different types of characters can I do in Unicode?
Mhm.
Let's see. Currently it has 100. Currently there are 143,696 different. 143,859 characters there. And I think we can. I'm just trying to see. There should be but it should be able to handle 2 billion. Oh, sorry, 2 or 4 billion. There's only so many characters in language. Unicode pretty much handles all writing systems that are currently in use. So,
okay, thank you.
Which leads to certain things, which is interesting because I could do things like this, because languages do support it. So I'm going to go ahead and look up the symbol for pi. I'm going to copy the text symbol for pi over here and paste it in here, like you see I did. And what I'm going to do is instead of num Macbeth lines, and Morgan, yes, you're correct, and I'll get to that in a minute. I'm going to replace that with pi, and print out pi. And you'll see it has no issues with taking a variable that's written in Unicode. Make sense?
Yes,
because modern languages are Unicode compliant. Now, why don't you get a lot of variables like that? Because I don't got a pi on my keyboard. That's why. Now, Morgan also had a question, I believe. So let me go and find my chat again because it's been moving around. Morgan asked, would that have been counting every time Lady Macbeth spoke as well? Yes. So this is the number of Macbeth lines plus Lady Macbeth lines because I haven't been able to, I did not specify Macbeth versus Lady Macbeth. There is a way I can do it though, because we do know that, so now looking at this file again, we note that basically when somebody speaks, it's just their name on that line. So what we could do is just simply say, hey, no need to do the splitting or anything. Let's just strip it and say, hey, if line is equal to Macbeth. And now we know that Macbeth has a total of 145 lines, because that's the number of times you get a line that's just that character. Malcolm in that case. Okay. So we've got that. That's how that works out. Let's go ahead and see what we might see in another example. Let's go ahead and drag something. So we can keep working with this file for right now. I'm just trying to see of what else can we do with this. So we've learned how to split a file up. We've learned how to read everything from a file. So let's go ahead and suppose we've been making a bunch of observations. We might as well show how to do this. So let's tackle file writing now. So I'm going to go ahead and create a new file in the same in the folder. File writing example. File writing is very hard if you're not working in Python. If you're working in Python, it's as easy as printing. So, so to write a file, let's go ahead and to write a file, you basically have to you basically have to say, this is the file I'd like to make. So it works the same way, which is open. I'd like to open, and then you say what your file wants to be. I'm going to call it output.txt. And then instead of putting a R, I'm going to put a W for write. Okay. Now write will overwrite whatever you do. Right. So be warned, if you give it the same name as something that already exists, it will overwrite what's already exists there. It says, I want to create a new file called output.txt and write to it. If output.txt already exists, I'm going to go ahead and overwrite it. I'm going to replace it. And I could call this anything I want. I could call this output. So I'm just going to call it output right over here. So, and the way you write out to a file, you go output dot write hello output dot write world, and let's see if that's enough. Okay, so I ran that code. Now I'm going to look in here, and I've got this output.txt over here. It's 10 bytes long. I've got hello world. Now, technically, one thing I should have done, I was just curious if it enforced it, but one thing you should do when you're done writing is close the file. So, right, we open the file, then we close the file. You should do that when you're reading too, but it's less important. For writing, it makes sure that everything that needs to be written gets written to the file. And it also lets Python know I'm done with the file. You don't have to, and the operating system, nobody's working with it. I believe it. I'm not actually sure if it interacts with the operating system, but I would imagine. Okay. But anyway, yes.
For that W, can you like write out the whole thing as just write, or does it have to be just W?
I think it's just W, but let's see. Nope, doesn't like it. It wants it wants W. It very much wants W and only W. Let's go ahead and check it. Open Python doc. Built-in functions. 1 second. So let's look at our built-in functions over here in Python in the documentation. Let's go ahead and click on open. So there's a bunch of different things you can do. You have R for reading mode. That's the default mode. R open for writing. X for exclusive creation, which means that if you're going to be, it fails if the file doesn't exist. A is open for writing, appending to the file if it exists. So here we're going to get into append in a bit, but that's basic. There's basically only 3 you have to worry about: read, write, and append. The other modes are binary versus text. we don't have to specify we're in text. It just assumes it by default. Binary is useful for doing open files. You can actually combine these, like write binary, but generally you'll just want to be working in one mode. But these are the valid characters that it accepts. Which ones do we care about? Read, write, and append. I was reminded that B and T existed by opening this. I had forgotten about them. They're not something I keep actively in my mind. Did not know that X existed, nor did I know that plus existed. So those are, so just to give you an indication of how often those things are used. All right, so read, write, append. So right now where I'm writing. Writing, we're going to do not nearly as much of. So writing, I run this and it creates a file and it says hello world. So how did I do that? I said, again, I've got this text.io wrapper, and what I set it to do was .write. You write to a file by using the .write method as opposed to the .read. And then you say what you want to write to it. Notice that I had 2 lines. Let's go ahead and can I view? Let's see. There we go. Isn't that convenient? Okay, so I've got hello, which wrote the first 5 characters, and world, which wrote the second 5 characters, right? Notice that didn't put any new lines or anything in there. It's not in, unlike print, it is very much, I'm going to do exactly what you tell me to do. I'm not going to add any characters that you don't tell me to add. So if you want new lines, you got to specify you want a new line, like so. Hello, new line, world. And now if I run this again, notice that this file is updated now. Okay? Makes sense? So, so that file is now updated. So, and notice that basically if I don't put anything in, it just deletes the file, it overwrites it. Right? Did you remember to close it? You need to remember to close it. Remember, and you got to check the file. Nothing's gonna appear down here when you run it. When you're writing to a file, you're not gonna get any feedback. Unless you print something out. Append mode is fairly straightforward to understand once you see it. Append opens up the file and adds to it. So notice I did hello world. I opened up the file, I added hello, and then a new line, and then world. Make sense to everybody? You use reading a lot more than writing. So let's go ahead and generate some random data for us, okay? Let's go ahead and generate some nice and random data for us. Okay. I'm going to go ahead and comment this bit out. Okay. And let's go ahead and I'm going to create another file. Output is equal to open some nums.csv. Anybody know what a CSV file is? Yeah, I know you do, but you're not taking this class. Yes, Excel. So Nicholas, you're very close. It's a type of file that Excel can interact with. The CSV stands for comma separated values. As we'll see, if you create a CSV file, you can open it up. It's essentially a text readable spreadsheet, a human readable spreadsheet. If you open it up, you can see it and modify it in a text editor. All it is a text file with a different extension, right? Yeah, and yes, ArcGIS, that would work. You'd find them as well. So I'm going to create a very basic file there. I'm going to remember to close it at the end. Output.close, right? And just to kind of run it to show you, right? Open it up, and now I've got some nums.csv, which the computer recognizes as something it can open in Excel. But notice it's completely empty. And if I make changes to this, like 4 and 34 and 2, save it, right? I can now open up the CSV file in here and look at that. Although it's separated by tabs. Typically you want to separate the stuff with comma separated values, but that's how I'm going to do it. Because generally it's easier to read with commas than tabs. Okay, so what I'm going to do is I'm going to generate some random data. I'm going to basically make some random temperatures. So let's go ahead and import random. Okay, and then we're going to do for I in range. So I'm going to build this up slowly. So for blank in range, let's go ahead and generate 100 random numbers first. So now what I'll do is I'll say random dot rand int from, let's say 20 degrees to 50 degrees. I'm going to say roll is equal to, so like I'm going to randomly roll a die here. Okay. 20 to 50 degrees. And then I'm going to go ahead and I'll say output dot write. I'm going to just do this slowly. And if I run it, oh, it says it needs to be a string, not an integer. So roll is equal to, convert this into a string, please. It doesn't like that it wasn't a string. And now I've got a giant string of numbers and text, because that's kind of not useful what I did there, because I didn't say to separate them. I'll go ahead and separate them with a new line. What I'll do to do that is I'll say, hey, roll is equal to turn it into a string, and then concatenate with this new line over there. There's a lot of different ways I'm going to do that. That's the way I decided to do that over there. And as you'll see, now I have 100 random numbers and a blank space at the bottom. Oh, well, blank space on the bottom. Okay, so now what I'm going to do is I'm going to then do, but this really isn't a comma of separated values. Let's go ahead and just get 20 numbers first. Let's reduce this to 20 numbers, easier to see. And now, rather than 20 numbers, let's make that 20 rows. And each row has 5 numbers. So for every row in range 20, I'm not going to use the row variable, but might as well. And what I'm going to do is I'm going to say, hey, for each row, each of these 20 rows, I'm going to say for item in range, and let's do 5 numbers. Okay, 5 numbers. So what I'm going to do is I'm going to create a random number then. I'm going to add a comma. Okay. In between it, I'm going to roll a number to convert into a string, add a comma and a space after it, and then write that text out. And then when I'm done writing these 5 numbers, output a /n. I'll go on to the next line. And then what that's going to do is text.io wrapper is not callable. Right. So there we go. I've got something that looks spreadsheet kind of like, although I've got a bit of an issue. What's the issue here? I mean, I can open it up in Excel, but And it opens up in Excel, no problem. But like aesthetically, what's the issue?
The commas at the end of the rows.
Yeah, the comma's at the end. The comma at the end. This is actually what we classic problem in intro to computer science classes, or that we first encounter in intro to computer science classes and kind of plagues you throughout. But the more you experience it, the easier it's able to be dealt with. This is called a fence posting problem, where basically you have pieces of fence and then you have fence posts, right? And you've got you've got your posts. You've got 5 posts that you want. So you let these numbers be the fence posts. And then we want 4 pieces of fencing between our fence posts. We've got 5 of these. We need 4 pieces in between. But often we have this extra one on the end, right? Kind of annoying. So a couple ways to deal with that. The first is that we could build the string all at once and just simply remove the last comma. So for instance, I could say, hey, I could say, so a couple ways to deal with this. One is to just deal with it at the end. Line is equal to an empty string. Here's our roll. And then rather than writing it, we'll say line is equal to a line plus the roll. And what we'll do is that we will output the line, everything but the last 2 characters, up to but not including the last 2 characters, and add a new line to that. That's one way to fix that, I would think. There you go. So that's a very Pythonic way to fix that. But another way to do that is to just simply, well, we want 5, so we're going to do 1 over here. And then we will do, so we'll do 4 in the loop, and then we're going to do 1 outside the loop without the comma. And do that with the new line instead. So there's different ways to address this, but it's a common problem that happens. But now we have a CSV file, which is cool because, again, we open it up in Excel, and Excel recognizes it as a spreadsheet, which we can work with. Incidentally, anything you do in Excel, right, we can totally do a save as, and then say, I'd like to save it as a CSV file. So you can take any spreadsheet that doesn't like have graphs or anything in it, right? And you can output it into a text format. This is actually how I handle a lot of your grades, by writing something that reads and writes files and compares names to your stuff. That's how I merge the runestone stuff, which will be, again, uploaded this week. So now that we've got these, we can do some interesting operations on this. So let's go ahead and I'm going to save this file, open. I'm going to go ahead and actually make a new file, see it, and I'm going to call it CSV example.py. Yeah, I always want to write CVS as well. I know it's inconvenient. Does it even stand for anything? I mean, like not ideologically. I mean, like abbreviationally.
Probably
Right.
convenience store.
Now I feel dumb. That's a really good answer. Annie, can you get the dog? Or can somebody get? No, you guys are.
Consumer value store works.
No, the dog wanted to come upstairs. All right, so let's go ahead and start by doing some basic things. Consumer value store. Interesting. Interesting. Did you know that, Annie? CVS stands for Consumer Value Store. That is a new fact for the day. That is not nearly as interesting as the fact that there are some animals with military rank, but it is an interesting fact.
You didn't know we in World War II we had the British had a bear, or was it the Russians? I had
The
no idea.
Poles. The Poles. The British are the one. The British. So there's the Norwegians have a penguin, but he's in Edinburgh. So, he gets promoted every time I think it's the Norwegians, but he gets promoted every time they visit. The Poles had a bear that helped them load artillery. Weird stories. Anyway, let's keep going. So let's go ahead and we want to read this file and let's do some operations. First, let's just go ahead and read it. To read a CSV file, since it's just like any other file, I'm just going to go open and I'm going to say, hey, file name, which is sumnums.csv. And then rather than writing to it, because I want to read the data, I'm going to say, read it, please. And I can just simply say like, okay, for line in text, right? Just to prove that I'm opening it, print line, right? Just to prove that I'm reading the same file that I opened, right? It's all strings, by the way. These numbers are stored in strings. So, Stephen, there was actually a soldier in the British Army who did basically fight with a claymore.
Yeah, I did. I can't remember his specific name, but I know there was a man who stormed D-Day with just a sword and arrow.
The last Native American war chief he won that honor for completing the I think it was 4 trials in World War II. It's pretty awesome stuff there. So anyway, continuing on, for line in text. So we've got these CSV files. So what I'm going to do is I'm going to go ahead and say lines is equal to CSV dot read lines. Okay, not CSV, open the text, read lines. There's a CSV class, but we're not going to bother using it. Print lines. So now notice that we've got basically a bunch of items. So for line in lines, print line, right? This should make it easier to see what we've got. Each line is a number followed by, it's 5 numbers and 4 commas separating them. And we've also got this space over here. So let's go ahead and start, formatting this for us. Line. Let's go ahead and do line is equal to line.strip, right? So we're going to strip this line of the white space. It's going to make it easier to read for us. Nice. And now let's go ahead and actually make it so that we're dealing with numbers here. So, or we're dealing with different items here. Line is equal to line. And so this is a comma separated thing. So we can just simply say, hey, line dot split on the comma. I think we can just get away with just doing the comma, even though we'll have random spaces in there as well. Like we've got space 24, space 26, but now we've got basically each number by itself, and then we can convert those into integers if we want to work with them in terms of data. So what we did, we read it, we dumped it into a bunch of lines. Okay, each line, what did we do? We took this string that was stored at that string, we removed the new line at the end, and then we split up the string into its component parts. In other words, the parts separated by comma. Okay, now that we've got that, there's we can say for item in line, what can we do? We can say, hey, int item. so we can kind of figure that out, and let's just print the number. So for every number in each of these lines, we're going to convert it to we're going to convert it into an integer, and then we're just going to print it out to confirm that it's working, that we were able to convert like that. Yep. So it didn't matter that there's spaces before the number that we're trying to convert. Now there's like a one-liner that we can do with lambda expressions, but that involves lambda expressions, and that's a can of worms I'm not going to open for us. So let's go ahead. For line in item, num is equal to item. So now we've got all of our numbers. So now we can do something like what is the largest value in this? Max is equal to, so biggest is equal to, let's say, negative. If num is greater than biggest, then biggest is equal to that number. Print biggest at the end. So we go through each item and ask, hey, what's the biggest number we found in this output? So the biggest number we found was 49, which occurs a few times in here. Okay, what about, what other things can we do with this? Well, we could figure out what the average is, right? So this one's a bit harder because every time I've been telling you to compute the average, right? It's just like sum it up, and you can do that in one line. Sum it and divide by the length of it, right? But that's not so easy over here. So what we're going to do is, to figure out the average, I'll do a running sum. Total is equal to 0. Numbers is equal to 0. So so every time we see a number, we're going to convert it into an integer. Then we're going to do total is equal to total plus that number. So we're going to add that number to our total. And we're going to say, so every time we see a number, we're going to add it. And we're also going to say, hey, the number of numbers I've seen, add 1 to that. Print numbers divided by, total divided by numbers. I'm like, I'm not doing something right here. Which is 34.37. So the average of all these numbers over here are 34.37. So a common thing I like to do for exams, which it doesn't really occur right here, is basically, hey, here's a data file. Please sum up all the numbers are in it, or compute the average, or give me some other interesting data. Generally, I'm not going to ask you for the median or the mode, at least with what you know. So first off, any strategies, though, of how you might figure out what the median value is? Right. So first off, what is a median, and how does that differ from the average?
The middle number in an ordered list of those numbers.
Right. So you take all the numbers, put them in order, right? Thing in the middle, that's the median. Danielle, let's keep getting an error in item. Value error invalid literal for base 10. Make sure that you're stripping out the commas, or you're not trying to convert something empty into the output. Because you're saying, so it all depends on what you've got. So yeah, in the median, what you would do is you'd make a list and sort it, and then put everything, and then the middle value. Congratulations, that's our median. Next, the next thing we would want to do is sorry, just thinking to myself. So what is the mode? What is a mode? Not what is the mode of all this data. What is a mode when we're talking about data?
It's the number that appears the most often.
It's the one that occurs the most often. Now, with the tools you currently have, it is possible to figure out what the mode is with the tools you currently have. However, it requires you to do some really crooked thinking, and your brain has to be really crooked to figure that one out, because you have to, it involves basically saying, I'm going to assign everything an index and say like, okay, I'm going to take these values and I'm going to store all the times I see 21 in index 0 and stuff, but it requires you to know the data, which you can't always do. However, next week on the next module, we'll learn about dictionaries, which does let us solve the problem of finding the mode. It's just a bit trickier. But generally on these kind of mathematical questions, I will ask you for the average, the mean, and then the biggest and smallest. If I need you to find some other stuff, it's going to be, I'll define it. So if I like asked you for the median, I should probably expect that. But the mode, I would generally define that as like, it's the value that occurs the most often. So this is how we do file reading and writing. So this is the kind of the basics. In our next lecture, we're going to learn some other stuff, like how can we do some Mad Libs with file reading. So how can we make a basic game? We'll also learn about making the world's dumbest computer virus, or the dumbest piece of malware, but it's very ineffective malware. But that's all I got for today. I mean, I wouldn't. No, you generally shouldn't. It's actually like kind of felony, believe it or not, to send malware to other people and have them run it. You'd be surprised what computer related stuff are felonies, like logging into your friend's computer using their password without their permission. Felony. Kid you not. Oh yeah, it is very surprising what gets counted in felonies as because it's a computer, right? You just say password and it opens. But think of it as the equivalent of bashing down a locked door, right? If you can't access it, if you're trying to get into it, it's essentially the equivalent of getting it through a locked door. It's really tricky stuff with the law. So basically, don't run malware without permission and stuff. I don't get the reference, sorry. So isn't this lecture and chat recorded? Yes, it is. But what you're going to see is that this is very dumb malware. Incidentally, some of the first malware was accidental, like, accidentally sending giant text files to people. All right, stopping the share. So